Let's talk about one-to-one functions. So our objective, determine whether a function is one-to-one. Okay, what do we know coming into this lesson? We know what a function is. A function is a relation that associates each input with exactly one output. Right, we saw in previous video lectures that different inputs can have the same output. The key here is that each input has only one output. For example, here's a function. This is the x squared function. Okay, the input of -1, when it goes into the function, the output is 1. The input of 0, when it goes into the function, the output is 0. And the input of 1, when it goes into the function, the output is 1. Okay, now, notice again that -1 and 1 have the same output. But notice that -1 only has one output. It only has the output of 1, and that's what matters. So in a function, you can have the same output. What you can't have is one input going to more than one output. Otherwise, it's not a function. Okay, and we know the graph of a function passes the vertical line test. So let's take a look. And let's take a look at our x squared function. So I'll go to y equals, I'll clear this out, and I'll say y equals x squared. Whoops, let's try this again. X squared, and I'll zoom to the standard window. Okay, and here is the x squared function. You'll notice that any vertical line drawn is only going to pass through the graph at one point. So that's the vertical line test for a function. Okay? Now, what is a one-to-one function? Well, a one-to-one function is a function, it's a function, which means it passes the vertical line test, which means every input has exactly one output. So it's a function that also associates each output with exactly one input. Okay, so here's the function piece. Each input has exactly one output. That's your function piece. And if this piece is also true, it's a one-to-one function. And each output has exactly one input. So if these two things take place, each input has one output, each output has one input, it's a one-to-one function. The graph of a one-to-one function passes both the vertical line test and the horizontal line test. Okay, let's go back to the x squared. Okay, x squared passes the vertical line test. Any vertical line only crosses the graph, in one place. But notice the horizontal line test, there are an infinite number of horizontal lines that cross the function's graph in two places. So the function x squared is not one-to-one. It is a function, it's not a one-to-one function. Okay, we want to determine whether the following are one-to-one functions. Okay, so I have these 5 points. Let's look at inputs compared to outputs. Let's see, the -2 goes to a 4. The -1 has an output of 1. The 0 has an output of 0. The 1 has an output of 1. The 2 has an output of 4. So every input has its own output. Okay, each input has only one output. Okay, that's the first part. Okay, now let's go backwards. Does every output have only one input? Well, this output of 4 has a -2 input. This output of 1 has a -1 input. 0 goes with 0. This output of 1 has a 1 input. Wait a second. this output of 1 has a -1 input, and this output of 1 has a -1 input. Not 1 to 1. The same thing with 4. Output of 4, the output of 4 has a different input. Okay? Outputs of 4 and 1 have different inputs. Therefore, my 3 circles, not 1 to 1. Okay? Again, 4, the output of 4 here and here has 2 different inputs, -2 and +2. Okay, let's check this one. Let's see, -2 goes to 6, -1 to 3, 0 to 2, 1 to 5, 2 to 8. Okay? Each input has only one output. That's our first test. Is it a function? Okay. Is it a one-to-one function? Let's take a look at our outputs, look at their inputs. 6 has an input of -2, 3 has an input of -1, 2 has an input of 0, 5 an input of 1, and 8 an input of 2. Okay, every output has its own input. Each output has only one input. Okay? This is a one-to-one function. Okay? It's one-to-one. Okay, let's look at, I'm going to look at 2 more examples using graphs and using the horizontal and vertical line test. Okay, I just wrote one down that I wanted to include. The first example, f of x equals the absolute value of x. Let's take a look. Okay, so I'll go to my y equals. I'll clear this out. Absolute value is a math key. It's a math number. So I'll enter and I'll put an x in there. Okay, and I'll graph it. There's the graph of the absolute value of x. I'm going to sketch that right here. It goes like this. Okay, that's the graph of the absolute value of x. Okay, vertical line test. Does it pass the vertical line test? Yes, it does pass the vertical line test. Any vertical line drawn goes through the graph in only one place. So it's a function. Okay, horizontal line test. No, I can draw a horizontal line right here and it crosses the graph in 2 places. Okay, I can draw a horizontal line in a lot of places and it crosses the graph in 2 places. No, so therefore not a one-to-one function. Okay, let's do the graph of x cubed. Okay, so give me just a second here to set up my coordinate plane. Here's x and here's y. Let's do x cubed. Okay, y equals, I'll clear out the absolute value of x and I'll put an x cubed. And I'll graph it. And here's x cubed. Okay, so that x cubed looks like this. That's x cubed right there. Okay, so vertical line test. Okay, if I draw any vertical line, do I pass through the graph more than one time? The answer is I do not. So the vertical line test, yes, it passes. Therefore, it's a function. Excuse me. The horizontal line test. Okay? If I draw any horizontal line, I only pass through the graph in one point. So yes, it passes the horizontal line test. Therefore, it is a one-to-one function. Okay? So a real quick look at one-to-one functions. And we're going to see in our next video lectures that a function must be one-to-one in order to have an inverse, which we're going to deal with quite a bit in upcoming video lectures.